Hi, this is the word solutions to your general term quiz. At the end of the quiz, you would have got your score out before, so if there is a specific question that you're looking for help on, feel free to fast forward to that question. Remember, you could also be using this to take additional notes if there's anything in particular you feel like you need a little bit of support with. And obviously, if you've got any questions at all, please just get in touch with us. So this is the first question in your quiz. It's asking you to find the coefficient on the x to the power of 9 term and the expansion of 1 plus 3x cubed all to the power of 4. Now remember, this isn't the same as your expansions. You cannot fully expand this and then find your answer. You have to use what we call the general term. So for your general term, similar to expansions, we're going to be using this power of 4 to help us figure out what we're writing down. So we are looking for the sum from r equals 0 to 4 of 4, which is our power, choose r, and we're then splitting up our terms, similar to like when we're doing expansion. So we've got our first part, which is 1, and we've got our second part, which is 3x cubed. So 1 is going to be to the power of r, and 3x cubed is going to be to the power of 4 minus r. Now remember, you're given that formula on your formula sheet, so you can go back and refer to that if you need to. So when we're working through this, we need to separate our x terms because we are interested in the coefficient of x to the power of 9. That's going to help us calculate your r value. So that line there can be simplified from the sum of r equals 0 up to 4. 4 choose r, 1 remains to the power of r, but we're going to separate this bracket out. So that 3 is going to have the power 4 minus r, and we're going to have x cubed also to the power 4 minus r. So that's separating our x out. And again, this can be simplified a little bit further. So we've got the sum from r equals 0 to 4. 4 choose r, 1 to the r, 3 to the 4 minus r. And then we've got powers on powers. So remember, if you've got a power on a power, you multiply your powers together. So we're going to have x 12 minus 3r. So remember, all of that has to get times by 3, that full 4 minus r. Once we've got to the point where we've got our x's on their own, we can then equate our x's. So I'm going to move over here and I'm going to equate x's. When we do this, we take what we've got, which is x to the power 12 minus 3r, and we set it equal to what we're looking to get to, which is x to the power of 9. So we want that coefficient of x to the power of 9. So that means that 12 minus 3r must be equal to 9. Negative 3r must be equal to negative 3. So r must be equal to 1. So we can now all combine all this information together. So we now know that the term we're looking for is 4, choose 1, 1 to the power of 1, times by 3 to the power of 4 minus 1, which is 3, times by x to the power of 9. So if we substituted in 1 in here, we would end up with 12 take away 3, which is 9. We don't have to do that because we've already calculated it over here, and we knew that we started off with x is equal to 9, so we can go straight to that. 4 choose 1, we know from Pascal's triangle, is just 4. 1 to the power of 1 is just 1. 3 cubed, so 3 times 3 is 9, times by 3 again is 27, and we're still timesing it by our x to the power of 9. If we multiply that all together, we get 108x to the power of 9. So the coefficient on x to the power of 9 is 108. Okay, so if you were asked that in an exam, you would write it out like this. This one we were asked multiple choice, so we know that our answer is B, 108. So for question 1, your answer is B, 108. So for the second question on your quiz, I would start off by rewriting it. Now, when you're doing your expansions, I think it's best to leave it as y minus 1 over y. It's easier to deal with. But in this case, I would suggest writing it as y minus y to the power negative 1, all to the power of 5. Again, that's just a personal preference. You can do it however you want to do it. This is just the way that I'm going to do it for just now. So again, we're looking at this 5. Our first term is y and our second term is negative y to the power negative 1. So we're looking at the sum from r equals 0 to 5 of 5 choose r. Our first term is y, that's to the power of r, and our second term is negative y to the negative 1, and that's to the power 5 minus r. Now this one's a little bit trickier because you've got that negative, but as long as you know how to deal with that, you'll be absolutely fine. So I'm going to start to simplify. I've still got my sum and my 5 choose r. I've got y to the power of r, and I'm going to separate this to negative 1, 5 to the negative r, and y to the negative 1 with our 5 minus r there as well. So by taking out that negative 1, I've now got a positive y, which is something that I can deal with. So keep going. I've got from r equals 0 to 5. I've just noticed I've put a 0 up here. That should obviously be a 5. We've got 5 choose r, y to the power of r, times by, and I'm going to put my y times together here. So I've got a negative 1 and a 5 to the minus r. So I've got y to the r minus 5 times by negative 1 to the 5 minus r. These two parts can get combined. So I've got from the sum of r equals 0 to 5, 5 choose r, y to the 2r minus 5, and I still need to times it by negative 1 to the 5 minus r. So up until now we've been equating x's, that's something that we're used to, but this time we're looking for a y term. So we're going to equate y's. So we have y to the 2r minus 5, and we're interested in y to the negative 1. So 2r minus 5 must be equal to negative 1. 2r must be equal to 4, so r is 2. So that means the term that we are looking for is 5 choose 2, y to the power, so if we substitute 2 in here, 2 times 2 gives us 4, take away 5 gives us negative 1, but we already knew that because that's what we were working towards, and we're timesing it by negative 1 to the power 5 minus 2, so negative 1 to the power 3. So using Pascal's triangle, 5 choose 2 is going to be 10, y to the negative 1 is same as y to the negative 1, and we've got an odd power on a negative, so that's going to stay as negative 1 as well. So I'm going to write it as negative 10 y to the power of negative 1. If I was just asked this in the exam, I would write the coefficient of y to the negative 1 is negative 10, but I'm given multiple choice here, so my answer for question 2 is A, coefficient is negative 10. Question 3. So this time we're asked to find the constant term. So the constant term basically means the number on its own, or in this case, the term before our a to the power of 0. So we've got a power of 9, our first term is a squared, and our second term is negative 2 over a. Again, I'm going to be writing that as negative 2 a to the power negative 1. That's just a personal preference, you don't have to do that. You can work through with that a on the bottom. So this time we've got the sum from r equals 0 to 9. 9 choose r, our first term is a squared, and that's to the power of r, and our second term is negative 2a to the power negative 1, and that's to the power 9 minus r. Again, I'm going to work my way through it. So I've got r equals 0 to 9, 9 choose r. So here I've got powers on powers, so that's going to give me a to the 2r. I'm going to separate this next part out, so I've got negative 2 to the 9 minus r, and I'm going to times this 9 minus r by this negative 1 to get the power for the a, so that's going to give me r minus 9. I've got a over here and a over here, so they can get combined. So I've got the sum from r equals 0 to 9, 9 choose r, and I'm going to put my number first. I'm then combining the two together to get a to the power 3r minus 9. So that's me got my a's individually. So to find my coefficient, I'm going to equate my a's. When I do this, I've got a 3r minus 9 equals a to the power of 0. So 3r minus 9 must be equal to 0. 3r must be equal to 9. So r must be equal to 3. So the term that I'm looking for is going to be 9 choose 3. Then I've got negative 2 to the power 9 minus 3 gives us 6. And I'm timesing it by a to the power of 0, because over here 3 times 3 gives us 9, take away 9 gives us 0, but we already knew that because that's what we were looking for. So 9 choose 3 is 84. We've then got an even power on a negative, so we're going to get a positive number. 2 to the power of 6 is 64, and we've still got this a to the power of 0. 64 times by 84 is 5,376, and that a to the power of 0 we can just leave off because it would just give us 1. So the coefficient on the constant term, or the constant term on its own, is 5376, which is D. So our answer for question 3 is D. Question 4 on your quiz is asking you to find the coefficient of 1 over x to the power of 13. So that's slightly different from what we've been doing, but we know that that's just the same as x to the power negative 13, so we can still do it the exact same way. On our expansion part, I'm going to rewrite this as 2x to the negative 1 plus 1 over 4 x to the negative 2 to the power of 10. So again, that's just to keep everything nice and straightforward. I'd rather work with negative powers in this case, unlike with my expansions where I would rather work with x's on the bottom. It's just a personal choice. So my power is 10. My first term is this 2x to the power negative 1, and my second term is my quarter x to the negative 2. So we're starting off for the sum from r equals 0 to 10. 10 choose r, first term to the power of r, and then our second term to the power n minus r, which is 10 minus r. We can then start to single out our x terms. So rewriting everything again, separating out my numbers, I've got 2 to the power of r times by x to the negative r. Powers are powers, you're multiplying them together. I've then got my quarter, 10 to the minus r, timesing it by x to the 2r minus 20. So that negative 2 gets multiplied by 10 and negative r to give me my 2r minus 20. I've then got an x over here and x over here. I can combine them. So again, the sum from r equals 0 to 10. 10 choose r, 2 to the power of r, and I'm going to put all my numbers over to this side. If I've got an x to the power negative r, and an x to the 2r minus 20. When I combine them together, I end up with x to the power r minus 20. So that's us now at the point where we can equate our x's. So we've worked out that x is to the power r minus 20, and we're interested in the coefficient of x to the power negative 13. So r minus 20 must be equal to negative 13, add 20 to both sides, so r must be equal to 7. So the term that we're looking at is 10 choose 7, 2 to the power of 7, times by 1 over 10 minus 7, so 1 over 4 to the power of 3. And then we've got our x to the negative 13, which is what we were interested in from the start. So 10 choose 7 is 120. 2 to the power of 7 is 128. A quarter cubed is 1 over 64, and then we've got our x to the negative 13. If I then multiply all that together, I end up with 240 x to the negative 13, which is the same as 240 over x to the power of 13. That's what we've been looking for. So the coefficient of 1 over x to the power of 13 is 240. So B is your answer for question 4. If you've got any questions about anything that we've went through, please just send us a message and ask.